everyone. My name is Nicole Christophe, and today we will see how we can manage an image. And I will start first of all with a question. Is there anyone who proceeds or work with images till now? Yes? No? Only two? The other? Do you have any experience? A little small one?
There's astronomical, like example pictures of stars.
Any type of images, any type. Yes? No? Okay. So because today probably you saw the program, we will have lecture and after that tutorial. Lecture, tutorial. During the lecture, you are free to ask any questions. So I'm here, I will try to answer to your questions. During the tutorial part, that will be good if you have any computer. I will provide you all the codes that we will see today, and I will show you also a small program, which is not mine, but it's free, open code, etc., etc. So you can try at home. If you are not familiar at all with the programming, that will be the best solution for you. If you want to develop your skills, that will be the Python code that we will see. Okay? So today I will start with the first and the beginning of the image processing. And let's start with the question, what is an image? Well, yes, there is a small text here, but how many images we can have? Do you know?
What do you mean how many?
How many types?
Two-dimensional, three-dimensional, or this type or what?
Okay, so if we want to say or label something as image, it's two-dimensional. If it's three-dimensional, it's become yes image, but or half and half image. That will be something between 2 and 3D. We will see it later.
Okay.
But the basic of the image is something 2D. So you have two dimensions, and you have a content on it. What is two-dimensional? Yes, we have x and y axis, and we have something visual on it. Here, I'm not familiar with the real content, but as I know, it's a galaxy, right? No? Yes? Or probably it's a galaxy. So today, that will be our best image to be proceed. Probably that will be good if we stop the lights, probably to be more visible, or we can make more processing of this particular image. We will work only with this one today. Okay, so we have some data on it. After that, what are the important things? Yes, we have content, but we have also some dimensions. Where is the position of the first 0, coordinate? Do you know?
No.
The top left corner.
Typically, usually, if we have some axis, it's here, the beginning, right? But for our proceeding, we will start from the upper left corner.
Because the CCD reads this way.
Exactly. Okay. So, if we want to react to this image or any particular image, we will start from this position. Because this is a dimension, it's an image which contains also pixels. The small part, this is the small particular unit, and we will store any information. That's the information will be for example, here, that will be the color, the information about the color. So, we have our small part of the image, we have its position. The position of this particular pixel is 0, 0. If you want to take this one, that will be, for example, I don't know, 1 50 50, 15 50, and 15 0 0. Okay, those are the dimensions. After that, because this is a grid, you can imagine as a table if you want. Did you work with tables? Excel, for example? Any other table? Yes? No? Okay. So you have a content, you have a cell, and you can put some information, some text, for example, some numerical data. We'll have here numerical data. Okay? And what I have done here, this is a visualization of the content. So we have our two axes, and we can represent our color as a third dimension. Okay. But this third dimension will be through from 0 to 255, which means we will have 256 values, including the 0. Okay. So typically, usually, we have dimensions of the image, we have the content. What can we have also? Any idea?
Well, if it's a CCD, then signal.
Okay, but
we can have the duration of the exposure.
Oh.
It
okay.
depends how it's generated, from a camera, from a program.
Yes, and we will pass through this during the whole presentation and the next presentations. Because if we do a selfie now, that will be a normal picture, right? But if we work with particular data, we need to see what type of information, including
Intensity, histogram.
Yes, we will see it. But you need to have in mind first to see how you take the data and from where. This particular image, I will show you, this is a link, it's LOFAR, and etc. etc. So, the color, and just to answer the question, how many pixels do we have? How we can count it?
This
The
one,
dimension.
like this one. Yeah.
Yes. So we will have the dimension. After that, the digital image, or as we can see in the previous one, we have some colors, right? Any color. How we can react to the color. When we were, for me, for example, when I was young, I liked to make some smileys, to color it, I use the yellow color. But if I would like to draw the grass, it's green. But if you have three colors, that will be the basic colors. That will be the yellow, blue.
Green.
No, the yellow and the blue will give me the green, and the third one will be the red. So if you take red and yellow, that will become orange, and if you take the green and red, that will give you violet. Okay, but here we have three colors depending on the color model, of course, but we have red, green, blue. To obtain the color, this is blue. but this is not the pure blue that we can have. This one, it's something like pink, right? Or this is yellow, right? How we can take them? So, for each of the three channels, channel red, channel green, and channel blue, we can take several amount of data and we can add them to one only particular case, and we can take the information about the color. So, for example, if we have the RGB color model, we can represent our colors in a box. This box is the color model of the red, green, and blue. What it represents? Yes, of course, we have the zero, the beginning of our axis. After that, we have our three colors. The first one is red, which means of this cube, this side of the cube will be the red. And the pure red, we can obtain it only here. Which means that we will have zeros for the other two colors. Here, it's the blue one and the green one. So, if we want to take the orange, or for example the yellow color here, we will have it somewhere in the cube. Okay? So, of course, in this cube we can visualize the magenta or another color space. It's yellow, cyan, magenta, and they are, if I remember correctly, this is the magenta, this is the yellow, and this is the cyan, somewhere here. So, the combination of the three colors will give you the value of the pixel. So, at the beginning, I said that the image is a grid, right? Okay, this grid contains some information. To achieve the color, we need to separate the three channels, which means we will have one matrix for the first color, one matrix for the second, and one for the third one. Okay, that they need to be with the same dimensions. The matrix. If you have this picture with dimensions m and n stands for the number of row and n stands for the number of column, we need to have the same dimension n and n for the red, for the green, and for the blue matrix. We cannot have one for dimension n-2, for example. We cannot proceed it.
Because we cannot multiply.
Yes. Actually, we add. We doesn't multiply. We sum the pixels. Sorry. The position. Yes. So here, this is the best representation probably for a picture, because we have 1, 2, 3, 4. We can count it. How many rows? How many columns? We can count it. You have some information here. This is a painting of something, you know what. But here you have only one pixel. Okay? You have here also one. So here we have one. If we can represent this drawing in pixels, if we have the information, we will color it. If we don't have any information, that will be 0. If we want to make it colored, we will have the exact same matrix. Let's take it for the three channels. The first one will be red. That will be red. This one will be green. And the last one will be blue. So to have, for example, this color here, we will have the information about the blue. For this particular pixel, we will take the information in the red and information for the same position for the green. So it's the sum of the three of them. What there is our image, and those are the three channels. I color it in three different colors, but actually they are. Sorry?
Day4.
No. They are only one, and it's gray. They have the values from 0 to 255, including.
So this is the luminosity, intensity of the picture.
Yes.
Okay.
The information about the color. How much color did you take to represent this particular pixel? Information in this particular pixel. So now we can split our image in the three channels. Yes, you can color it as you want, but they are black or without any information, which means here, if we move down here, we have the information about the blue, and probably that will be 255. We don't have information for the green, that will be 0.
0, yes.
And for the red, that will be 0 also. So here, to have the information, that will be 255, and that will be the white color. And we don't have any color at all, that will be the black one, represented by zeros. If we have a small quantity, we can measure it, so that will be, for example, 1 to 10, between 0 and 255. Till now, is it a little bit clear? Yes? No? If you have any question, don't hesitate to ask me. Yes, we saw the three channels splitted, but we can have our original image and after that to compute the grayscale. Why is it important for you? For example, why we need to do it anyway?
Because it shows intensity.
We can compute the intensity here also, but yeah. We can get the best images and, for example, with the best resolution, with the best color. The technology is developing the image processing, let's say like that. So if we want to take the best information about the object, we can take it with the bigger resolution, because here, what will be the resolution of this image? You have details, right? Let's color them. I will color each pixel where we can find your object. Do you know what we have here? If I'm continuing drawing.
Yeah,
The signal in blue channel.
Yeah, that will be okay in the blue channel, but look the pixels.
There is signal in these pixels.
the bigger the pixels are, the more inaccurate,
Yes.
inaccurately colored it is.
Yes, exactly.
Huh? No. What does it mean? Pixels?
Okay. If I split, this is the dimension of our pixels, right?
Uh-huh.
This is the dimension, the same dimension. We can count how many pixels we have.
Okay.
Okay, so here, for example, you know that there is something.
Yeah, there is a line. Yeah.
There is a line.
Yeah.
Okay.
So,
But can you represent this line as dimensions, like the same dimension of our pixel?
no.
Exactly. So if you want to achieve the, let's say, almost the same dimensions, you can continue splitting the pixel
Yeah,
to
this
obtain
is the
bigger
resolution of the
resolution.
matrix. Yeah.
Yes. So that will be the explanation of your colleague that mentioned. That if you have bigger resolution, you can achieve best results.
Yes.
Of the content.
Yes.
Of the content.
But depends if you're just an image or if it's a CCD matrix. Because then you need to know the size of the pixel. But this is other story. Yeah.
Yeah. So why we're talking to pass from the original image to a grayscale image. In the original image, you will have the 3 channels. In the grayscale image, you will have only one. And if you have, for example, an image with small quantity of pixels, the processing time will be not so long. But if you have image with a high resolution, and if you need time to proceed it, the computational time will depend, of course, of your machines, but you won't have enough time to proceed it. Okay. Bigger resolution, that means bigger time for proceeding.
Yeah, for sure.
And because we will see in the end, and we will talk about the AI, you will see that the computational time will be the preliminary things, let's say like that. You need to think how many times you will need to proceed the data, and is it crucial to have it in online, on real time? You will understand.
Yeah.
You will understand. Okay, so here we will have the same dimension. We can use this formula, which is from the literature, of course. And in the end, we can obtain the information about the pixel itself. We can obtain the histogram and the frequency of each of the values. And what we can see here, we have a peak overall, let's say 40, right? We have the pixel value. We can have the values from 0 to 255. 0 is the black one, and 255 is the white one.
White.
And somewhere here, overall 1 50, 150, we have a small peaks. You can see, yes or no?
But what is this frequency on the?
The frequency of the
This is
pixel,
What does it mean?
which means that if we count, can we stop this because it's too hot?
Yeah.
Would you like it? No. 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 This is
Any other
no.
one?
Okay.
The other.
Some here. Okay. Sorry about this, but it's become really hot. I don't know where is it, but okay. I will die. Well, we can count how many pixels we have in 0, which means they are black one. We can count it first for the first row. We can count for example, we will have 5 zeros. We can have 2 pixels.
This is
containing-
how many, let's say, this color is represented how many times in this picture?
Yes.
Okay.
We're talking about the colors, not the information in the image, like what it's represented, like information, like object. We're looking only for now the colors.
Yeah.
Okay, so here what we can see that there is one object or something which is big, which takes almost 90% of the image. And here there
There's
is
something else
small. And we will see what and how we can manage it. So now we can have another color model which is hue, saturation and value, and we can represent it as a circle, of course. Here is a circle and the beginning, and a cone, okay, where we can add each of the colors that we have, but represented as hue for example, the saturation and the value, the brightness. So, what will be the color itself? We can add it somewhere. That will be 360 degrees, right? We can draw this circle in 360 degrees. Okay, so probably in the literature it's mentioned that from 0 degree we can start, of course, but that will be the beginning, and we can draw or find the red color, the red channel. After that, in 200, this is 90, up here, we can find the green one, and at here, that will be the blue one. We can search the color somewhere here. And the common problem in any image, that will be the noise. Okay? So what type of noise do you know?
Dark noise, glass noise.
For CCDs, there was a type of noise called dark current.
Yeah.
Okay.
This is the same, dark noise and dark current.
Yeah.
This is caused by the dark current.
Other types? Try, don't.
Maybe if we have some pixels in the image that represent the feature, and we have unwanted pixels or pixels with unwanted values around that feature.
This is booming of the CCD.
Maybe something like blurry image.
Yeah, this is when the pixel is oversaturated.
Yes.
And light goes to the other pixels that is not real value of the.
Yeah, like artificial signals.
Yeah.
Okay, but can we have, for example, information that will be added during the during the taking process.
Yeah, the temperature of the electrons that takes the.
We can produce any type of noise during the taking process. We can achieve, let's say, noise with the compression also.
Yeah, for sure.
So,
No, we don't achieve noise. We degrade the quality.
Yes, the quality, but we can. Let's assume that you need the quality.
Yes.
If you small the quality, if you increase it,
What?
how you will increase it?
If I increase the quality,
Decrease, sorry.
the quality,
Yes,
how I can increase it?
decrease. Going
Yeah, if I
lower.
decrease
Yes.
the quality, so what?
Yes, you will apply some type of algorithm. Okay.
Okay.
And during applying it, you can achieve some information that won't be really wanted in this particular case.
Okay.
So that will be the noise also. But it can be caused by different variety of factors. And sometimes we will want to add a noise on our data. Yes,
Why?
you will see.
Okay.
And something also, yes, there is probably the last slide with a lot of text. But what is the importance here? The format. And when you start, for example, to save any information, you need to think how you will proceed it, right? So, what is the common image format that you store your images?
It depends what is the image.
All these, pretty much.
Yeah, but the most
JPEG?
part.
The first JPEG.
Yeah.
And that'd be the worst of your purposes. Because it's lossy compression. Which means during the saving process, you apply a compression algorithm which will throw away the quality.
Yes, but you can also choose what is the level of the compression.
That will be good to choose another type
Yeah.
of storing of
PNG
the
or
image.
TIFF.
Yes. So today we will work with the PNG form
Okay.
because it's lossless, which means we will have a bigger size of the image itself,
Yeah.
but we will have the quality. And about the colors, how we can store the colors. Why we need to prefer, for example, the PNG, because we can store any type of quantity of the color itself. And some quality metrics. Why we need to do it? Because we will have image processing, and when we proceeding, we need to measure how good was this proceeding itself. Okay, I will move and I will explain you these two particular formulas. The first one is signal to noise ratio. I forgot one P here, so sorry, I saw it now. It's PSNR, or with only SNR is signal to noise ratio. Okay, so peak signal to noise ratio include the mean square error, and the mean square error is calculated as we have our original image. Our original image have rows and columns, which can be represented by n and m. Okay, we will have two counters. The first one we will count how many rows we have. The second one we will count how many rows and column we have. So we need to find the difference between the particular pixel in the particular position of the original image minus the obtained pixel value in this position. Okay?
No. Again.
Okay, so you have your original image and you have done some proceeding. Okay, you achieved the same image but proceeded. Let's say you do something.
Yeah.
Well, this formula tells us that we need to pass through each of the row and column to proceed each one of the pixels. So we need to find the difference between the, let's say this is our original image
And the proceeding.
and the proceeded one. And that difference will be in square. Which means if here we have, for example, we need to obtain a positive value. So for example, here if I have 5 in the original image, and after the proceeding I obtain 7, the difference between them will be 5 minus 7, which will give us minus 2.
Which tells us what?
Which tells us that
How much the proceeding was what?
now we have the difference.
Okay, but
Okay,
what tells me this information for
the
me?
information that you will need the whole quantity, not for the particular pixel here, but for the whole image. So, for example, you will see what is the mean square error. That can be a value from 0 to 1. 0, which means 0%. And if you have 0%, probably it doesn't have any proceeding at all.
Oh, so it gives the value of the processing.
No,
Of what it gives?
give me one more second. Okay, 1 give us 100%. If you obtain mean square error, what is the error? If you have error 100%, so I can make a photo of me. After the proceeding, that will be my photo, but probably with another face. Or different color of my face. Or, I don't know, probably I can have, I don't know, but probably I can be a doll. So, your proceeding, the object which is included in your image will be lost. If you have an error, typically around 10 to 20%, that will be good. 20% of error is,
Very reasonable.
yes, it's reasonable. Okay,
So this tells me how.
how good you proceed your image.
Yeah.
The best result will be to go through 0, because signal to noise ratio, peak signal to noise ratio, will be measured in decibels. And if your peak signal to noise ratio is lower, that means that you proceeded well, because it's included in the formula.
I want to ask you something about the second formula.
Yes,
That means
this
for-
one.
Yeah. So after the sum signs, we have E of I and J. So this is the signal in a specific pixel. of the matrix.
This is the information stored in the particular pixel.
Okay. And E prime.
That will be the preceded one. So E and
One is
G
the
will be
original
the original.
and the other one is the preceded one.
Yes.
Okay.
So you compare both and you see how much the preceding affected your original image.
Yeah.
This is the point of this.
Yes.
Okay.
Any other question? Till now? No. Okay. We continue.
This is signal to noise compared in the processing itself, not in the
Yes.
electronics and anything
No.
else. Okay.
During the processing itself.
Okay.
Okay. So till now we saw some particular information describing an image. Now we can start to proceed it. And it's referred to different manipulation. When we talk about manipulation, what is the first association that you have?
Edit.
To edit the image. But what we can edit, let's say like that. So we can proceed, for example, the first part will be color space compensation. We will have our original image in RGB color space. For example, we can compute it in grayscale. Most of the algorithms pass through grayscale image, and I explained it why. Or, for example, you can pass through HSV, hue saturation. Okay, so what and why we need to do it? Probably if we stop the lights, that will be more visible, but you can try it at home also. I will give you all the codes to obtain those results, okay? You will have it. So, for example, here, I don't know what is the real content. I know that this is galaxy, but what are the attributes of the galaxy? I don't have any idea, but I can see the colors. So I can see that there is something small, which is probably, let's say, yellow. So that, for me, tell me that I can try to obtain it independent color, false color. Yeah, that will be the false color. And to try to find something that I cannot see in the first one.
Yeah.
From the original one, yeah. Next, what I can do, I can do some resizing. If my image is, for example, not a square, and I will need a square, I can resize it, giving some dimensions to, for example, 450, or I can tell I will scale the image, or I can increase the resolution. I can do it. So to have more pixels.
Yeah.
Cropping. Probably you have used what? Some doing it by
Snipping tool.
okay. Here you can do it also, but that will be the advanced part. You can find your object automatically. We won't do it in here. Yeah, there is algorithms that can tag your object through the all image. But what is the idea? To find your region of interest, and that will be really important. You need to know that if you crop an image, and this is your region of interest, this one, it won't be good to cut it to the real values. It will be good to focus your object in the center of the cropped image and to have around 10% of information which is not included to your object. 10 to 15%, because now you cannot see if your object, probably you can think that you cropped well your object, but probably during the proceeding process you will find that there is information that you can cut. The next one will be image enhancement. Yeah. So this technique will improve the quality or the contrast. We will see the first one will be the stretch image, and the contrast stretching is given by the formula itself. We will have the image, the values of the image. We will have 0 as lower pixel value, and the upper limit will be 255 if you have 8-bit images. So if you have 8 bits, which means you have 2 square 8, which means 256 values. And you will store it from 0 to 255. Here you can change your limits. You can say that your lower one will be 50 and the upper will be 200. It depends, of course, of your, for example, your histogram. If you turn back to the histogram, let's turn it quickly. Oops. Here, if you look at your original grayscale image, you can see that the both are in the around 50, at the value of 50. It's almost black. And if you look at it, you can say that, okay, I have my object here and the other is unusual information. I don't need it. So you can skip all of this part. You will take it away. Okay? And you will search, the information will be here, it's a 0, around 0. So you can cut it.
Yeah.
And you will search and you will proceed all values from 50 to 200 for this particular example.
Can I ask about
Yes.
Instagram?
Yes.
So,
Yes.
So in this one, for example, if I see a feature like with a big peak
Yes.
like this, and I saw another peak for another feature that I cannot see with my eye, is it possible to label or to identify which pixels
Yes.
correspond to this small peak?
Yes. Yes, you can do.
Sure.
To see,
Otherwise, they won't be there in the histogram.
I mean, like, for example, there is another hidden feature in the image that
Or do you mean hidden feature in the...
Feature in the feature. Attribute of
The
the feature.
hidden feature also should be in the histogram.
Everything will be here.
yes, but for example, this small peak, which feature?
Yes, you have 2 peaks actually here.
Yeah.
You have 2.
Yes.
One is pretty visible, the second one is small one.
So are these two blobs around the pixel in this image?
Here
No.
This histogram is representing the image.
itself, this one.
Okay, and which one?
The small peak, where is it on the picture?
You can proceed it to see. Here, probably for me, because it's around the values 250. 250 is gray. The gray like your jacket. So I will search the gray, and the gray is here. So this huge peak from the both of them will be here. That will be the the first big, the second package. And the small one will be probably those two.
Okay, what about this big one?
The big
This is
one
the black.
is the black.
Oh,
Resizing, cropping, enhancement. After the enhancement, we can find our particular object that it's stored in those small toothpicks that we have solved, okay? Because we clean the another part of the original grayscale image. We will have only this one. Another type of image enhancement will be the histogram equalization. And histogram equalization, we will try to correct, let's say like that, the peaks, the two peaks, and to don't have one in the beginning, we will try to stretch it over the whole values. And the result will be this one. After the image equalization, the result.
And the point is?
The point is, if you have here, it's not really the good example of image equalization, but if you have something that it's hidden,
Yeah,
let's say
okay.
like that, in the black part of the image, you can find it. Here, I can say that there is a pattern. You see, there is something here, there is something here, 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 and here also.
Yeah.
I don't know what is it. I have no idea. But I can see it. After that, you can do some filtering. And the result of this filtering is by applying a median filter. What is the median filter? Do you know
No.
about the filters? Okay, I will explain you. So you have your image, you have your pixels, and you will have your filter. The filter have also sizes. Typically, you have 3 by 3, 5 by 5, 7 by 7, etc. So you will have.
This is what grouping of the pixels.
This is the size of the
No,
filter.
3 by 3, 5.
This is the size. 3 row, 3 column.
Yeah, grouping of the pixels.
Yeah.
Yeah.
Okay, you will have 9 positions. Okay? Count. What is the purpose of the filter? No matter if it's a median filter or any other type of filters. You need to add it first at the beginning of your, let's imagine this is the filter, okay? You add it into the beginning of your image. And you need to proceed each row and each column through your image. After that, you will go to the second row, third, fourth, etc. It's up to you to decide what will be the moving part of your
Step size.
the step size. Yes, thank you. The step size of the filtering process. It's up to you. And what is the median filter? You will have 3 by 3 and you will put it, that will be without any information. We will know that you have only 9 positions. You will add it first at the beginning and you will proceed it. For this example, you will put your filter, for example, it is in this position. And in the original image, you will have those values. Okay? Those are the values of your original image. What medium filter does, you will take all the noise and you will put it in an array, and you will find your median value, which is the value in the middle, and that will be your value. That will be the
Medium of the whole signal.
medium of this particular place.
Yeah.
And each template will take a value and we will sort it from the original image. That will help you to take away some noise if you have one.
Yeah.
And you will obtain some false values, of course, after filtering, but those false values are not so false if you count the signal to noise ratio and you obtain it around 10%. It will be completely wrong if you obtain, for example, 50 or 60%. Yes.
So how can we play around with the parameters of the filter in order to get into that 10% range? Like maybe reduce the step size or increase it, or the
That
size
will
of
be
the
the-
filter?
Actually, that will be the manipulating of the data. You will try to manipulate your data to obtain the best results for this particular image. But what will happen if you change the image? And you will have, for example, you can obtain the step size for your current image to have step size, for example, 1. And you need to proceed your image, right?
Yeah.
With this step. What will be the computational time? If you have step 1. What will be the computational time if you have step equal to? Do you need to, you need 7 by 7? Yes, 7. You can manage the size of the filter. But what you will have if you have a smaller resolution and you use a bigger,
You do indeed.
yes. So it's up to your data.
But these are the two parameters of that filter that we play around in order to get into that 10% range.
Or you can work with the filtering, because there is a type adaptive filtering, and we will see it probably in 1 or 2 slides. If you have a noise, for example, in your original data, here I will show you 2 possibilities. The first one, if you have your original data and you can try to clear the noise. For me, I don't know what is the type of noise, if there any noise at all in this image. I can try to see what I will obtain. Or I can add additional noise to the original one, and I will try to filter it to see what will be the difference. So here will be my grayscale image with different watermark. And after that I will apply a median filter. Here this is the adaptive median filter, which is different than this one that I showed. Adapting, which means that you will recalculate again and again, depending on the histogram that you have at the beginning. So you will receive better results if you adapt the value of the filtering, not only the size or the step. Okay?
But this is a noise removal when you don't have dark frames.
What you mean about dark frames?
dark frames is when you take a picture of a sky. First, you take picture with the lens covers to take the picture of the noise of the electronics in the CCD matrix, so the CMOS matrix. And after that, you take picture of the sky as usual, and you remove the noise when you. This is the dark frame, dark noise.
And that will be the 000 values.
What will be the zero?
What will be the content of your dark image?
You have red and black pixels. The red one, the heating from the electronics. The red, and you remove these red pixels.
Okay.
That will be also in your astronomical image when you take it usually.
Okay, and do you think that you will achieve removing it? Yes, of course, this is important part. But do you think that you will obtain the real value of the pixel in this particular?
Yes, I do it when I take, let's say, I take 50 images with a lot of time exposure. Let's say 10 minutes, 15 minutes, 1 hour. Then I increase the signal to noise ratio of that pixel. And when I increase the signal to noise ratio to the pixel with 1 hour exposure, I can remove the noise of the electronics because it will be smaller, the signal.
Okay, but now if you need this filtering, I understood now your question. This filtering won't include your part of the work. Okay, you will work with your result of this proceeding.
Yeah, this proceeding is when I don't have dark
Yeah.
frame, and I only try to remove the noise as it is without dark frames.
Yes. After that, I have 3 more slides, and we will pass through the tutorials. So here is the image normalization. We will normalize what we can normalize.
I think I didn't get the point on the previous one. Sorry. But
What we were talking about, the dark frames?
that was a sidetrack. I wanted to understand more of what you were trying to present on the previous slide.
Here.
Yes.
Okay. You are a specialist in your field.
Mhm.
Me, probably I'm a specialist in mine. When you have something in mind, and you will have your pre-proceedings before the image to obtain the real image, the original image. Okay. For me, I don't need to know how really is obtained this particular image. Yes, of course, that will be success if I have information about the lens used to take it, about the pre-proceeding that you applied. But for me, this is only an image.
Okay.
I don't know what steps you go through to give it to me.
Okay.
Probably, I won't say that you make a mistake, but it happens. Sometimes we can think that we can proceed the image in the correct form, but if you develop a new technology, you will need some proceedings to obtain a better result. Okay. During this process, you need to try, in theory, something, and to do it in real world is something else. Okay. So here we are trying to obtain a better result of what we are looking at. So here, I don't know if you make a mistake during your proceeding or not. Probably no, but I need to verify
To check
it.
it.
Yeah. And for me here, I will try to clear all the information because you see there are pixels, which is some information. But is it necessary information or not? I cannot know also. So I will try to remove that.
These are different noise removing filters, and you apply them separately to check which result will give you better result, which filter will give you better result. In your case, to get more information from the object that you picture.
Real information. Necessary information, describing information.
Because different filter is different mathematical operation over the pixel and the pixel information stored from the system matrix.
This would be only if, like you said, I tag my object and I'm interested in that object. The rest I want to get rid of.
Yes.
So first I would tag it so it doesn't mess with it. Then I would apply a bunch of adaptive filters. And when you say adaptive, does that mean that they're actually adapting based on the first parameter that you show us about how much sigma we get?
That will be also adapted. Yes.
Is this the parameter they're adapting on?
Yes.
To minimize it.
Yes.
So you basically tweak how much error you can accommodate. Let's say you fix it at 10% and the filter kind of does all the magic and it brings it to 10%.
Oh, yes. Yes,
Okay.
let's say like this. Yes.
Okay.
So image normalization. Usually, yes, of course, it's depending on the content, but you can have, for example, images with value 0.01,
Mm-hmm.
the value of the pixel
Mhm.
content, or minus 1005.
Why minus?
You can have minus.
Why?
For example, for the color representation, it's depending on the color space itself or the proceeding. During the proceeding, for example, you can have the blue one will be minus 1 and the higher value will be 1.
Okay.
You can have. So, to proceed your image, that will give you some difficulties with the minds. So that will be good if you set your values to something that you know, that you already know, and you can proceed. For this particular example, I set my range from 0 to 135. But if you want to change the value, that will be from minus 1 will be your 0 and 1 will be your 255. So you need to manage your all values through this range. And
Does this introduce noise?
the introduce noise.
Yeah,
No, the noise that actually
the
the
pictures-
noise. No, this is the noise that you already have.
Oh, so it kind of brings it up.
Yes,
Okay.
and the next part will be image pre-processing and data augmentation. That will be in the next lecture. Do you have any questions?
I have a question. It might be a bit general, but let's say if I have an image with so many features, but I don't know which features are actual objects or real objects and which features are noise. Is there a way to differentiate between the noise and the features? Like if the noise has some characteristic shape in the histogram? maybe?
Okay. in this particular case, you need to ask a specialist in the field of the content of your image. Okay, because here, your colleague told me, this is a noise. For me, I don't know is it a noise or not. Okay, so probably you will, he will have more knowledge to know what is a noise and what is not a noise. For if you are looking for a galaxy, I don't know what is the black one. Here, I don't know what it is. No idea. But if you are focused on the galaxy, so the other stuff are noise. It's not important for you. Okay?
So it depends on what I want to achieve, right? Like,
Yes.
For example, the noise might be important for some other applications.
Yes. For you will be the trash, but for somebody else will be a treasure. Okay, so for the data augmentation, it's the second part of the presentation that will be after the tutorial. This is a small bibliography that it's important. So I told you that if you are not familiar with the coding, you can try a software which is really open code. It's not mine, but you can find it here. It's ImageJ. You can try it. It's really simple to work with it. You can visualize your color space, for example. I can show you. That won't be.
Who made that software?
Sorry?
Who made that software?
Honestly, I don't know.
Because the domain is .gov for government.
Probably.
And
I don't know. I really don't know. We can enter and we can see, but it's really simple, not heavy as a program. It's easy to be installed in Windows or another operating system. The images, the image that I used. You can find it in the gallery or so far, and because I took one image from the internet, this is for the media filter for the example that I showed you. Okay. Now, about the tutorial. How many of you work with Python? Okay. So I have the Python code, and for the tutorial part I will show you this particular code. I'm not really familiar where we will add all the presentation and all the tutorials, but if you want I can put it in some drive and you can take the link from there. Give me 1 minute just to find something to.
I think it's from over there.
Because it's, I cannot read. No, it's a volume.